welcome back to the AWS Cloud and DevOps hands-on implementation series. This is the video 7 and today we will cover two powerful services that help you to build modern, scalable and cloud-native applications. We will start with Amazon RDS, a fully managed relational database service, and then move on AWS Lambda, which lets you to run backend code without worrying about the servers. Whether you are building a web app, data pipeline, or an IoT platform, these two services are must-know tools in the AWS ecosystem. So let's dive in. Let's start with Amazon RDS, which stands for Relational Database Service. RDS is a managed service by AWS that makes it easy to set up, operate, and scale a relational database in the cloud. It supports popular engines like MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server. Think of it as a smart assistant for your database. Normally, managing a database involves installing database software, applying security patches, configuring storage, and setting up replication, handling backups, and tuning performance. With RDS, AWS takes care of all that heavy lifting for you. It's especially useful when you are building application like a blog, an inventory system, or an online store, any app that needs structured data and strong consistency. RDS offer automated backups, point-in-time recovery, monitoring, multi-agent high availability, and read replicas for scaling read-heavy workloads. Plus, you only pay for what you use, and you can easily scale your storage and compute capacity as your application grows. So, instead of worrying about infrastructure, you can focus on building great apps with RDS. Ensures your database is secure, available, and fast. Now let's create an RDS MySQL database instance on AWS. First of all, I will show you how to create RDS, and next I will show you how to connect with MySQL Workbench. First of all, log into your AWS Management Console and navigate to Amazon RDS. Click on the databases. Click on Create Database. Then select Standard Create. Standard Create is for full control. Choose MySQL as the engine and then select version MySQL 8 point. Keep it as it is. Edition is MySQL community. We have selected engine type MySQL, and database creation method is standard create for full control. Here you can see information. MySQL is the most popular open source database in the world. MySQL and RDS offer rich features of MySQL Community Edition with the flexibility to easily scale and compute resources or storage capacity for your database. Now make sure you choose free tier template so you don't incur charges. It is great for testing and learning. Remember this step, template is free tier. Next, set the DB instance identifier to something like MyDB. Leave the default master username as admin. Credential, click on the manage self manage. Create password. I have created master password and then confirm the master password. Now under the instance configuration, stick with the default DB t3.micro. 2 CPUs, 1 GB RAM, network speed is 2085 Mbps. Scroll down to the storage, leave it 20 GB and check the enable storage auto scaling box. Additional storage. Enable storage auto scaling if This feature allows to store storage to increase after the specified threshold is exceeded. Maximum storage threshold, keep it is as it is. In the connectivity section, use the default VPC, and subnet group is also default. Set the public access to yes. This is important because if you want to connect your database from outside AWS, such as MySQL Workbench, so public access must be yes. Under the VPC security group, select the default. Default is selected. Keep password authentication on as the method, database authentication method. Leave other setting as it is and click on the create database. It will take few seconds or few minutes. So wait. Create database. I will solve this issue. Now click on the create database. It will take few minutes. Wait for few minutes. I will pause the video till the database is created. Now the status will change to available because it is ready. Now I will show you how to connect the RDS database with MySQL Workbench. Let's connect our RDS instance using MySQL Workbench. Once your DB status is available, copy the endpoint, click on the MyDB. Here you can see the endpoint and port. Copy the endpoint. Open the MySQL Workbench. Uh, Click on the plus icon here. For connection name, give name my RDS connection. In the host name, paste your endpoint. Port is 3306. Set the username as admin because we have given master name admin. Click on the store in vault. Here, give your password. Okay. Click on the test connection. Wait for some time. If it is timeout, you likely need to edit your security group setting. Go back to the RDS console, click on the your DB, then click on the security group, default security group. Click here. Go to the inbound rules. Click on edit inbound rules. Add rule. Choose all traffic. IPv4 anywhere. Then save the rules. Return to the MySQL Workbench. Now click on the test connection. Give your password. Okay. Fail to connect. I enter wrong password. Test connection. Give the password. Now successfully made the MySQL connection. Click on OK. OK. Here is my RDS connection. Click on this. Now SQL editor will open. Now we will create database. Create database sample. I hope you all know MySQL Workbench. create database successfully, then use sample db, correct. Then we will create table employee employee id and employee name HR 55. Table is created successfully, and that's it. You are now created an RDS MySQL instance and connected using MySQL Workbench. Data protection is built into RDS to help you safeguard your information. Automated backups. RDS automatically takes daily backups during the backup window you set. You can use this to restore your database to any point within the retention period, which can go up to 35 days. It is great for disaster recovery. Then manual snapshot. These are on-demand full backup you take manually, especially useful before risky changes like schema updates or software updates. If something goes wrong, just restored from snapshot to new database instance. I will tell you a real world example. Imagine you accidentally drop a critical table. If you had a snapshot from last night, you could spin up a new instance using that snapshot and recover all your data with minimal loss. Avoid unwanted charges. Manual snapshot do not expire automatically and can incur storage costs even after the original database instance is deleted. Same with the backup enable instance left running. Here I will show you how to delete everything safely. Go to the RDS console, click on the DB. Here click on the actions, then delete. Uh, Now this step is important. Uncheck the final snapshot. This also uncheck. I acknowledge that upon the instance deletion, automated backup, including system snapshot and point-in-time recovery, will no longer be available. You have to uncheck all of these. Type delete me. If you click on create final snapshot, then because of this snapshot, you will get charges, as I said before. Manual snapshot do not expire automatically, and it incurs the storage cost even after the original database is deleted. So click on the delete. Deleting status is deleting. That's it about my RDS. By cleaning up the snapshot and terminate database, you ensure you are not paying for the ideal resources. I hope you understand the RDS database. Now let's move on into the serverless computing with AWS Lambda. Serverless doesn't mean there are no server. It means you don't have to manage them. No provisioning, patching or scaling. You simply write your code, upload it to Lambda and AWS runs it for you, automatically handling the scaling, availability and fault tolerance behind the scenes. Lambda is event driven, meaning your function run only in response to the event. This could be an S3 upload or an HTTP request via API gateway, or a message from SNS or SQS, or a scheduled cron job like every hour or every day. You are billed only for the compute time your function uses, down to the millisecond, making it highly cost efficient. Use cases are running backend APIs without a server, automatically processing uploaded images or files, sending emails on user sign up, running daily cleanup job or analytics pipeline. In short, Lambda lets you focus on writing the logic, not managing the infrastructure. Let's create a real AWS Lambda function that triggers automatically when file is uploaded to an S3 bucket. Our goal is log the file name and size using the simple Python script. Go to the AWS console. Our database is deleted successfully. Now click on search for Lambda. Create a function. Click on the author from scar. Name your function, for example, log S3 upload. And then runtime, choose Python. All languages are available here. We will write Python script, so I will choose Python. This is the runtime Python. For permission, create or select an execution role that has S3 read access and CloudWatch log permissions to write logs. By default, Lambda will create execution role with permission to upload the logs to Amazon CloudWatch logs. Keep architecture as it is. Other setting keep as it is. Click on the create function. Now click on the add triggers. Search for S3. Click on S3. Choose your target bucket. We have to create bucket for this. Search for S3. Create bucket here. I hope you remember the steps for bucket creation. S3 bucket. Name should be globally unique. Click on create bucket. Bucket is created. Go to the Lambda. Refresh. Now you will see a bucket name. Under the event type, select all the object, create the events. Add. I acknowledge. Add. In the code editor, use this Python script. Function is Lambda handler. It will take event context. File name is S3 object key. File name it will take status goes to 100, and we will get the message upload log successfully. Now click on the deploy. Successfully updated the function log S3 upload. Now go to the S3 bucket and upload any file in this bucket. Upload. Wait. Click on the test. Save. Add file. Upload. Uploaded successfully. Now go to the CloudWatch log. CloudWatch. Go to the CloudWatch, click on the log groups in the log section, click on this AWS Lambda log S3 upload. Under the log stream, click on this. You can see file uploaded. Now I will show you another file upload. Click on the bucket, upload, add file. Upload. Now go to the CloudWatch, refresh. See, file uploaded, file name, end request. That's it about Lambda function. With just few clicks and the few lines of code, you have built real-time automation using AWS Lambda. Let's walk through how to expose a Lambda function via HTTP request using API gateway. Go to the AWS Lambda console. Click on the create function. Author from scratch. Give a name, any name. HTTP. Runtime, choose Python. Other setting as it is create function. Inside the code, keep the code as it is. Now scroll down to the add trigger. Here type API gateway. Select create a new API. Choose HTTP API. You can choose WebSocket API, REST API. Then click on the add. For security, choose open. Open means no authentication. Anyone with the URL can invoke your API. It is good for quick testing or public APIs. Click on the add. Your Lambda is now linked to a public API endpoint. Now go to the API gateway dashboard. Here you can see endpoint. Click on this endpoint. Here you can enter the stage. Click on the create. Stage name, let's say production. Click on the create. Deploy. Choose prod. Deploy. Successfully created deployment. For this deployment is active for prod. Now go to the route section. Click on the create. Define your route. Let's say gate prod. Create. Now deploy. Choose stage prod. Deploy. Successfully created. This deployment is active for prod. Click on the gate. Deploy. That's it all about Lambda. After setting your API gateway, you link your Lambda functions. You invoke URL. This URL is the endpoint where you can access your Lambda function. You can test this URL using tools like Postman or browser. If you get this route, you will finally look like this. This is your API access point enabling HTTP triggered Lambda invocation. So together Lambda and API gateway make a powerful serverless combination. It is perfect for building scalable APIs without any infrastructure. I hope you understand the Lambda function in AWS with API gateway, and for our first example is upload S3 file. You will get triggers in CloudWatch events. wrap up with a quick summary. In this video, we launch and connected to Amazon RDS with MySQL database, learn how to manage backup, snapshot, and restore, understood the serverless computing, and created a Lambda function with S3 trigger, explore how to expose Lambda via API gateway for real-time HTTP-based workloads. Coming up the next, we will learn most important topic in AWS, that is networking with Amazon VPC. You will learn how to design a secure and isolated virtual environment. You will configure subnet, routable, internet gateway, NAT gateways also. We will launch EC2 instance inside custom public and private subnet. This sets the foundation for deploying production grade cloud infrastructure. Thanks for watching. Don't forget to like, share and subscribe for more hands-on AWS content. Thank you.